Okay, so what we're going to look at in this presentation is some web attacks. So as part of this, we'll have a look at the metasploitable infrastructure to be able to see how we can actually train against a known vulnerable instance. Then we'll look at how we can use proxies to be able to intercept our web traffic and change the communications. And then generally we'll have a look at some other threats such as backdoors, dictionary attacks, code injections, SQL injection and link modifications. Okay, so as a background, here are the top 10 OWASP vulnerabilities related to web. So we can see here they've not really changed that much, and the injection is still one of the top ones. It was in 2003, 13, and it is in 2017. Broken authentication is also a strong contender for the top vulnerabilities. Cross-site scripting has dropped from 3rd into 7th place, and some new entities have came along. So this includes XML, external entities, broken access control, and so on. And it's normally these top 10 vulnerabilities that we look for when we're actually scanning for web vulnerabilities. Increasingly, our testing moves much more up into the higher level layers of the protocol stack. Okay, so this is what HTTP looks like. It's a fairly simple protocol. We've kind of fossilized it since HTTP 1.1, and basically what we have is we have a request and then a number of options. So it can be get, post, head options is the request. We define the page that we're after and the protocol that we're using, and then there are a number of options which go along with it, separated by new lines. So the user agent defines the browser that we're actually using. The host might have defined the name of our computer or its IP address, and so on. In this case, we're keeping the connection alive, so we don't want to break the connection once we've got our page back. HTTP normally does that. It's asynchronous communications. So in this case, we're making sure that the connection is staying alive because it's likely that we're wanting to be able to access something on a page. Okay, so here are some of the options here. We can define that we don't want an update if it's not been modified since a certain date. So what comes back is a response code. So 200 is okay, 404 is file not found, and so on. 500s are typically server errors, 400s are client errors, and so on. So this is the response here that comes back, and it's all in a single page. So we see here we've got some header information that gets stripped off by the browser, and then below it is the actual page. Okay, so that's how HTTP actually works. The two main HTTP request commands are get and post. So get, we post the variables after the page. So in this case we have two variables, val1 and val2. That's a value of 10. That's a value of 20, and they're separated by ampersands. The question mark here defines the end of the page and then the start of the variables. So in this case we're doing a get with the variables, and then we have these extra options. So then name value 1 and value 2 are passed into the page. Okay, and then we get a response such as this coming back. A post is typically used where we have a form. So a form here, between the tags, every value, every input value between the tags will get posted into the form. So in this case, this is the form that the page that we're going to call up when there is an action. So the type submit is a button. So when the button is pressed, the values of these text inputs will be passed back with a post. So we can see here, here's the post, and the post doesn't actually have the variables in it, but it's part of the post that goes back. Okay, so in this way we can pass values into our form. So in this presentation we'll be using Metasploitable 2, and the three main applications we'll be using is the DVWA, or the Damned Vulnerable Web App. So it has lots of vulnerabilities in it, such as weak usernames and passwords. The PHP MyAdmin as part of Metasploitable, so that will be used for some SQL injection, Matilde, and also Matilde, which will be used because it has PHP scripting vulnerabilities. Okay, so you should never set this on a publicly available website. So the demonstrations in this presentation are all available as a tutorial and have been recorded, so you can play them back. Okay, so let's look first at web discovery. So with web discovery, we can use our simple tools such as mmap to be able to find the services which are running and find out a bit more about the server. So in this case, we're scanning just for two ports, 80 and 8080, and we can do a no host discovery as part of that to make it quicker, do a SYN scan, and then we can also use the -sv to be able to find the service information. So in this case we can see here that we've discovered that we're using Apache Web 2.2.8. The logs which appear, and on a Linux system we'll look in var log Apache access logs, we should see our accesses appearing with inside the log files. So in this case, when we put in a head there, slash, then we should see that appearing in the access logs. So in this case we've used Telnet on port 80, but we can also use netcat NC to do the same kind of thing. So what's coming back here, as we can see, it's PHP and it's Ubuntu and so on. And so we've discovered it's using PGP, it's a Ubuntu 5.10, and it's Apache web server. Okay, so this allows us to be able to examine the service by connecting to it. One tool which is used to be able to discover the infrastructure of the web server is Nikito. So Nikito allows us to be able to scan a certain IP address or range of IP addresses, and then it will show us things like the PHP info page is available, there's a doc directory test, and so on. So in this case it will give us some information about the scanning and possibly about any vulnerabilities that we might have. So in this case we can see here that the server has doc and test, some folders on it. We can also use the Dirbuster application. So with Dirbuster it will try and search for well-known directories on the site. So in this case we define a target, we then define the list of directories and files that we're actually looking for. And for that we can look for file names and directories, and we can also go recursively down the folders. Okay, so in this case this is what Dirbus has actually found in the results. It's found a whole lot of directories. So in this case we should be able to look in this file here, and it will give us a list of common names of folders. So now let's look at some backdoors that were common in the past. So often web developers will put in, or developers of services will put in a little backdoor just so that they can get back in quickly. So here's a couple. So it happened on the VAS FTP daemon that if someone put in a username of backdoor smiley face, they didn't actually need a password, and they could actually get connected onto the system because it opened up a port 6200. So once you put in this, then you go to this port, and then you don't actually need a username and login for the telnet connection. When we put in ID semicolon, we can see here we're writing as a root access. So it's a pretty severe vulnerability. Another one is the Unreal IRC server. It had a backdoor in it, and Metasploit can actually send the right command to be able to exploit this. So when you try this, you should find that when we do our ID again, semicolon, we are now in root level. This distribution CC is for C++ compilation, and Metasploit again can actually open up this, create a session, and then when we do ID, when we open up the command shell, we can get root access there. The SMB is used many times to create a connection onto a remote machine. So in this case, we can actually see here, this is the root account logging in here, and there are a number of shares. But what we can do is that we can try to take access to one of the shares, such as temp. So in this case, there's a vulnerability here that allows us to be able to create writable access to temp. Then once we have that, then we can go and use our SMB client, and we can see there that we have anonymous login. But more worryingly is that we can actually grab the password file from the etc folder. So we now have admin access. This one here is another Samba vulnerability, So again, we can see we're connecting in, and we create the exploit, and again we can get in there and we can use commands such as ID. Weak passwords are an obvious area of vulnerabilities. So what we've got to watch is that we don't allow any login to any user accounts just because they have weak passwords. Okay, so the Metasploitable instance has a number of weak passwords. So these are defined in the shadow file. So here is an example of the shadow file. We can see here we have a 1, which is a salted value of MD5. The bit after it here is the salt, and then this is the hash here. So we can see here that John the Ripper easily is able to crack these passwords, and it's found that MSF admin has a password of MSF admin, user, and so on. For sys, we have a password of Batman, and then we can actually show the passwords that we've actually managed to break there. So John can also use a word list. So in this case, we're using the RockQ word list against the shadow file. And we can see here it's went through and it's managed to crack these ones here, such as klog, sys, Postgres, and so on. Hashcat2 can crack these passwords, but we put it into a slightly different format. So in this case, a 500 is the type 1 here, which is a salted MD5. So the first part here between the dollars, the second part between the dollars is the salt, and this is the hash. So hashcat goes after that. And you can see here that it's managed to crack the first one here, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're using the RockQ list. So one of the most successful for an adversary is often what's called an intercepting proxy. So an intercepting proxy catches a lack of authentication, a modification of parameters, and so on, and will take a valid transaction, put it through a proxy, and then modify it in some way. Software developers often don't test for this type of vulnerability. So what we can do is that we can set up what's called the burp suite. So burp suite is one of the top packages that's used inside this type of web scanning. So within our instance, in this case I have Kali, we set up a proxy on a host, and then the proxy runs on a certain port, in this case 8080, so that anything which is destined for something on the web will be sent through the proxy. The proxy can then examine it and then forward it on to the end machine. Okay, so what we're going to do is we're going to look at some PGP, some PHP vulnerabilities for this example. Okay, so when we access this page here, which exists on the web server, Burp Suite will intercept it and then we'll either forward it on to the website or we'll modify it. Okay, so when the proxy is run, when we run Burp Suite, we look at proxy, we intercept, and then we define our interception is on, and then we look at the raw parameters. So in this case, it's basically just an access to the website for its top level folder. After this, we define whether we repeat it, send it on, or we want to intercept and change it. So if we right click here in our raw format, then we can send it on and we can modify it. Okay, so we can then look at the intruder, and with intruder we can go for a snipper type attack, and with the snipper we define the thing that we're going to snip, add it here, and we take our request and then snip it. So we're going to snip around the login area, and we're going to actually put in different names that can be used, so that we'll be modifying that one field. We can have multiple fields that we modify too. Okay, so in this case we're then going to define the payloads that we're going to use. So it's one payload, and it's just going to be a simple list, and from there we add in a number of options for our list. So these are going to be the pages that are actually going to be accessed for the PHP code. And then when we run it, what we see is the success or not. So a 200 means it's been successful. And then what we can do is we can click on the name of the file and actually see the request here, and then also the results. So the HTML will show us what comes back, and then the render will actually show us what the page actually looks like. So in this case, this is admin.php, and this is the result that came back when it's actually rendered. So it's been successful. So 200 means that the page was successfully found. Now let's look at a dictionary type attack. So with the dictionary attack, we can use Hydra. So with Hydra, we can have a user list and a password list, and then we can do a host post form. So in this case, it will take certain parameters and then actually modify them to create a post. Okay, so we're going to try the login page here. We use a username, and the username will be, in this case, when we use this special variable name, it will take it from the user list. and then this one from the password list. And then we'll try to log in. Okay, so that's how Hydra does it. But we can also do it in Burp Suite, and we can do it with what's called a cluster bomb. So a cluster bomb allows us to try multiple variables in here. So we'll add in again the things that we're finding interesting. Okay, we'll capture one login, and then we're going to try a cluster bomb which will be able to try multiple entries. The next type of attack is an injection attack, and it's fairly common with inside web attacks. So with this, we're using this page here. So it does a basic DNS lookup. So the target host comes in. So the user puts in the target host here, and then whatever appears in this box here appears there. Then what actually happens is that that name that appears here is echoed straight to the page. So if that happens, then it's possible to inject some code for malicious purposes. And what we often do is that we can take two requests, and then we can put it into a comparator. So the comparator will take the two requests and the replies, and then give us the modifications. So in this case, we can actually see the modifications that actually happen when we use google.com and intel.com. So you can watch the demo to be able to see how this actually works. But it is possible too also if a name is going directly from this text box into the derived page, it's possible also to inject some script. So in this case, this is a perfectly valid script. If it isn't checked, then this script will fall straight through into the page, and in this case it will cause a pop-up alert to be shown when we do a DNS lookup. So it's injected some code in there. Link modification is quite a powerful tool for an adversary. So with this, we'll inject some script this time into the text box. Again, it will go right through and then appear as part of the rendered page. So what happens here is that it finds the A tags on the page and then creates the first link to be BBC. So I think this is the first one here that appears. So when someone clicks here, they'll actually end up going to the BBC page. So obviously someone could be fairly nasty in changing the links on a page, and it looks like a perfectly valid page, such as for Google, but the actual link goes to someone else. A code injection is still a fairly serious problem with inside web infrastructures. So with code injection, we can directly inject JavaScript, which can be malicious. So in this case, this site here hosts this JavaScript, and then that has been injected into the page, and that could do fairly nasty things, such as creating a form and a button for user login within a perfectly valid page. What we often do too is we send in a canary. So a canary allows us to be able to take a valid request and then add, say, the word canary. We'll then use the comparator to find any occurrences of the word canary in the response. So this is the example here where we've taken the user login and used the word canary, and then what we can do is we can actually find wherever the word canary appears, which means that that word has went straight through into the rendered page. So an example here is the code that we can see from the comparator, and then an intruder can actually craft an input string to be able to terminate JavaScripts and then inject some code. So in this case, if we add a password or an entry of this string here, it will actually terminate this response correctly and then add this extra response, which is alert 0. What we do in order to stop the JavaScript from being seen, then we convert it into an encodable format. So we use the URL encoder string for this to be able to render this string into HTML characters. So we often spot the %20 for a space, and there's a space here, and so on. SQL injection is still one of the top threats, and this is where an SQL command goes straight through the code and then arrives at the database. So in this case, here's an example here where we're accessing a page with a database on it, and we're logging in this case. So the password here is Fred. So a fairly common statement for SQL is this for PHP. Okay, so where when the user is logging in, whatever's in this admin text box and the password text box will actually go through. So when the user logs in with admin and password, this is the request that's seen. But if we now modify that and the password becomes inverted comma space or 1 = 1 hyphen hyphen, then it actually terminates the password, and then the OR statement makes the whole statement true no matter what the password has been entered. So in this case again, we can enter the password in a URL encoded format. Okay, so that was a brief introduction to web attacks. You'll find the associated demonstration and lab associated with this will be able to give you the skills that are required. Okay, thank you.